All right. Hey, everybody. I think this is working. We're going to sit here and make sure because, it's been a while. And the streams, they do weird things. But I see myself over there, so here we go. We're back, App 2025. Today we're covering serverless reporting with Amazon Athena. If this is your first episode or your first time joining me here on the channel, thank you. If you're coming back, thanks for joining. It's been a while, I know. Things have been crazy. Today, we're going to go over how to query the data that we've generated from our next generation application. And so we'll go back and we'll review the architecture pretty quickly so that we see how it all got in there. And then we'll go in and query that data with Amazon Athena. So that's one of the first things we'll talk about is just what is Amazon Athena as a service, how we can use it to query that data that we've stored. The other SQL characteristics that it has, like we can create views for our applications and where you should create those views. We're going to take a quick stab at visualization of our data with Amazon QuickSight, which is a business intelligence product that helps you visualize your data into meaningful dashboards, charts, and graphics. And then we're going to cover the registry of open data on AWS so that you have some understanding of some of the available data that's out there that you can either ingest into your application or ingest alongside your data with QuickSight to enrich it. And then we'll save some time for Q&A at the end. So before we get too deep into this, I want to give you a couple little caveats, right? So one, when I originally planned this episode, it was back in May, and they were occurring every week. And so I wrote a simulator to generate transactions, put them onto the event bridge, event bus, and process them, and eventually write them out as data. And a couple days before the show was scheduled to air, I caught an error in it. So I said, well, instead of doing them at a rate of 10 a day, I'll run them at a rate of 10 a day, or of 10 a day, I'll run them at a rate of, 10 per second. I multiplied it by 10 and said, I'll run it at 100 transactions per second to catch up. And then the episode didn't air. And it was going to air the next week. So I was like, well, I'll just let it run. And then it didn't air. And then, y'all, I left it running. And that's like production levels of transactions per second. So the good news is we have a lot of data to query. The lesson here is definitely pay attention when you're simulating transactions because it's a lot of data that gets generated. Can you see the bill? I'm pretty sure our boss has already seen the bill, buddy. It's actually not that bad, y'all. It's something for close to 1 billion run-throughs of the entire system, everything, for which is like a month's load of transactions end to end. It came out to under $5,000, which is kind of, not in your account this time. Which when you consider that's, all your high availability, the fact that all of these transactions are being processed in milliseconds, it's essentially like the workload of an entire business, $5,000 a month on a bill with no optimization and just like stabbing stuff in there intentionally sloppily to get it out the door. Pretty good, pretty effective. I don't know how many EC2 instances that is, but considering there's no, we didn't have to run OLAP data store, we didn't have to run a data warehouse, any of this stuff. We just chunked stuff through our step functions workflows, stored it in S3, and here we are with a bunch of data now. So I'll be washing the AWS dishes for a while to pay for that one, but learn from my mistakes. And then the other thing is today there's not a whole lot of code. So I'll push that code for the simulation of transactions up for you to look at. Again, be careful if you run it. I won't push it up with 100 transactions per second as I had it. But for the most part, we're going to be in the console today, which maybe this will be your favorite episode. Maybe this will be your least favorite episode. I don't know. There's going to be lots of clicking. And the thing with that is it's not really deterministic, and I'm not very good with the console. So I'll ask you to bear with me as we click around in here, because even though I've gone through this several times, my comfort zone is being in the CLI and doing everything as code. So, hey, we'll see how it goes. But let's talk about Amazon Athena first. Amazon Athena is a service that aggregates your data from multiple locations. In our case, Amazon S3 buckets where you've stored it, and allows you to run SQL queries against it. It's the Presto SQL engine, which syntax-wise is very similar to Postgre syntax, if you're familiar with that. So it does have its own quirks and characteristics. And in fact, if you look in the links here, which we'll share in the chat, there's a link to Athena SQL to its own flavor there for you to go check out. Whenever you're writing Athena SQL queries, that's always a good place to start. But it's priced by the amount of data that you pull in and out for your queries, right? Which introduces a couple concepts. One, you want to store your data compressed, and you want to store your data in an efficient format. So you can store your data in there as CSVs, but it's not efficient to read or extract or store. So you're going to be paying more than you need. We'll go back and look at the code that we wrote in the Kinesis Data Firehose episode. We actually stored our data in Parquet format, Apache Parquet, which is a columnar format. And the advantage of that is when you're doing scans, you're only reading the columns that you need. So you're only reading the data that you need, and you're not paying for the rest of the data. Excuse me, y'all. I'm glad I got the mute button this time. Usually I miss it. But so really, if you can, you want to be storing your data in Parquet format, especially as your data grows and as you have to read more and more of your data. You also want to consider partitioning your data. We haven't done that for this episode. It's a pretty complex topic, but by partitioning your data, you can query only inside those partitions, typically by date. So you can query only in a certain time range that matters to you, and you limit the scope of the data that you're looking at, which A, increases your performance, but B, also decreases your cost. So again, you'll find information about that in the Athena docs, which are linked here in the links command. And then one last housekeeping thing, if you're looking for the repo for this series right now, it's temporarily down while we resolve some things and migrate it to an official repo. So that's the good news, is it's going to be up under AWS samples, and we'll be living on as a permanent repo. The bad news is it's not available right now, but it will be available again soon. So appreciate your patience on that. So let's go back and let's look at our diagram really quickly. And let's sort of see where we are for a quick refresher and how we got here. So if you remember, the Amazon Event Bridge Event Bus is the backbone of our application. And as we move across the bus from left to right through time, we put events onto the bus. And rules listen to those events, filter those events, and kick off workflows, AWS Step Functions workflows, which represent our business processes. And we've gone through how to use those workflows for long-running processes with standard workflows, how to use them for quick-running processes with express workflows, how to do service integrations to write data into DynamoDB, or to, in our case, into Kinesis Data Firehose so that it gets into S3 buckets. That's this split that you see right here. A single event can be captured by two rules, and in fact was in our service, one of which sends it through our online transaction processing system through a step functions workflow, and the other of which sends it into a raw S3 bucket where it can be converted to Parquet and stored in our processed bucket using AWS Glue. But so all of this stuff that we've built, we still haven't provisioned any servers. We still haven't provisioned anything that runs when we don't have business events. Everything start to finish is still serverless for us in this architecture. So that's how we got here. I'm not going to go through this code, but just to jog your memory, in the billing component of our app, that's where we used an AWS Glue table and a Kinesis Data Firehose to write that information into an S3 bucket. And you see we've used the deserializers and we've written it out as Parquet with some other configuration options, okay? So all of this was from the Kinesis Data Firehose episode, which was the last one that we did on May 12th, I believe. So if you don't remember how we got to here, maybe it was May 10th. Anyway, if you don't remember how we got to here, go back and take a look at that episode and see what we did with Kinesis Data Firehose to write these records into an S3 bucket. So before we get into Athena, let's take a look at that S3 bucket. We know we have the raw data bucket where you can see for some time here from May 20th to June 6th. I wrote some raw records into this bucket, right? And so all of these are just the JSON objects that were sent out through the event. And you see there's quite a few of them every hour. We go back, we also have the process data bucket. And this is where we see the partitioning that's been done, even though we're not using it. And in here, all of these are Parquet files. And there's fewer of them because they're packed in the way that they're done. They're packed in and compressed. So we have all these items in our S3 bucket that we can go back and query against. So that's where we're getting this data from when we're in Athena. It views that database as the glue database that we defined. So yes, it's coming from S3, but Athena thinks that it is a glue database. It's just that the glue database then knows that that table is located in S3. And that's relevant because you can put tables in different places so that you pull all of that data together, and Athena queries it in a federated or a unified fashion without needing to know where all of that data came from specifically, just sees it as a glue database. So now when we go back over here, this will be a fun one. We've got this transactions table that we created with the customer ID, the date times of the events, source accounts and destination accounts. We can see where it's flowing and the total amount. And we can begin to run SQL queries against it, right? So the most basic is just to figure out how many of these records we have over the entire life of me fire hosing records through this thing. And this will take a second, not too long, right? Runtime, 10.5 seconds. Didn't actually scan the data. So there's 174 million records in here, right? And then at this point, we've got all of Presto SQL available to us. We can sort them by amount. We can look at them by date. We can perform the analytics transactions on them, like average and standard deviation. We love you, man. Keep going. Thank you. I love you all too. You all are the best. So you get all that power from, let's look at this link real quick. Athena SQL, from the Presto SQL language here inside those queries. Now, this isn't the only way that you can use Athena, right? You can do API calls to start executions of queries. You can save named queries that are then accessed by other components of your application. You can restrict access to those queries using IAM roles and permissions. So it's not a query in the console service. There's a lot that can be done here. And then of course, as we will see in a minute, you can also use this as the backing for QuickSight, for Amazon QuickSight, so that you can derive your BI there. Very thirsty because I just came off a stream with my man, Eric Johnson here. So I've already been talking a lot today. A little pause there, a little quick pause. So let's see what other ones I have. Okay, so here I have this view that I've created as an example. You can create views here inside Amazon Athena, and you treat them just like views in any other relational database, right? They're compiled, they are efficient. You can query against them by name without knowing how they're necessarily constructed when you get into permissions. You can also create views inside Amazon QuickSight, and we'll see that. And it's kind of up to you to figure out where is more effective for you to put that view. If it's something that across the business people will want to see, like you're aggregating glue tables across S3 buckets that belong to different organizational units in your company, then you may want to create that unified view here in Athena so that people across business units can query against that entire set of data. If you're creating something for yourself, like you have a report that you send out or that only belongs to a dashboard, then you may want to do that inside Amazon QuickSight, right? But you have the option to do both, and we'll explore that in a minute too when we get all clicky. But again, just as from that links document there, the Presto SQL, this should be a pretty standard SQL for you, right? 50 years. Woo. Create or replace view name as a select statement, right? And so in this case, This is just the substring syntax from Presto SQL. So we're starting at the first character, taking 2 characters. And then what we've given ourselves here is this, I think we have a preview here. Yeah. We can run this query using that preview command, and it just grabs 10 of them for us. So we have, I'll be honest with you, I don't know all of these country codes. I apologize. I feel like I should. I'm imagining that's Macedonia, Hungary, Luxembourg. But we can see sort of, okay, this is the shape of the data that I expected to get out of this view, right? And I can see the source country, the destination country, and the transaction amount. And now here we get into like actual use cases, right? So if we have a whole list of financial transactions, we can go and say, show me all of the transactions from the Benelux region to Cyprus, right? If you want to look for a trade agreement or for renegotiation of transfer pricing or for anti-money laundering or for, you know, what do you call it? Market segmentation pricing, right? Like differentiated pricing. Whatever your use case is, these views can shape all of that data into what you need so that you can then drive your intelligence off of it. And again, don't forget that Athena can be queried via API. So it's not just here in the console. You can embed this inside your applications, even for like real-time decision-making, for fraud detection, for other sorts of, you know, say you have a minimum level of transaction that must be achieved lifetime before you start doing something, and somebody applies for that. You can do that query over the life of all of their transactions, and because it's stored as Parquet, it's columnar, it's going to be a very fast query, a very effective query, regardless of how many records there are, and you get that answer back programmatically in a step functions workflow, say, right? So let's see what else we have in here. Create or replace view country info. We've done that one already, and that's the same as this. And then selecting the counts. So we could sit here and we can write SQL queries all day, but I think it's more interesting to take this into QuickSight and see what we can actually visualize with it. So let's go over and go to QuickSight. I don't know if I've deleted my account so I can show you how you get started. I have not. When you first go into QuickSight, it's something that you have to enable. You have to select the plan that you want to be on, and you have to create SSO. So just be aware of that. There is a cost to this service. And again, it's not the only way for you to visualize your data. It's just a tool that's here for you that I want you to be able to see. So let's manage some data. We're in North Virginia. That's not where our data is. So let's jump over here. Oh, look, I was even in here. So we can open this to see what I built, and then we can look at another one. This one, we've just built a little, a heat map is one of the built-in visualizations that we have. So you see we have heat maps, tables, line charts, donut charts, donuts. All these different types of built-in visualizations, as well as Insight, which offers you ML-assisted insights into your data over time. In our case, what we have is, this is probably going to take a while because it's seeing this data for the first time. But if you, let me see if I can make this larger for you. In the field, well, what we're going to have are source country code by rows and the destination, wait, that's this. And then the destination country code by columns. So we're looking at transactions from Benelux to Cyprus, Great Britain, and Ireland, a typical tax audit or investigation that you would see, right? And the values is going to be the total sum. And if we look, we have some applied filters here that give us those values, right? So here we have a drop-down custom filter list, very easy to create. For the source country, we only want to see transactions coming from that view. I'll be honest with y'all, I haven't run this report against 174 million transactions before, so who knows what's going to happen here. You can select the countries that you want to see here and apply it. The same thing for the destination filter. So that's why we see that it's the from one country to another, and then the titles are there as well. Here in our visualization, let me go check my data sources to make sure that we're doing what we want to do. Manage data. Your data sets, transactions. So it's from Athena. You can apply row level security. I don't think we want to duplicate that data set. But if we edit it, we see that transactions is coming in from, yeah. Table name, transactions. With, these are calculated fields that we've added. So you can add that as well. So we're not actually using the view here. This is what I was talking about when we could either add data from the country info table and query that country info table directly, or I'm going to remove that. We can add calculated fields ourselves. And so for these, what we've done is we've applied that same Presto SQL of substring to the destination account to get a destination country code, right? So there's a couple different ways that you can do this. If your analytics users or your business intelligence users are comfortable with SQL, they can apply it themselves. But you also have the option of giving it to them internally. So let's get back out of here, manage data, your data sets. We can add a new data set, and there's permissions that you need to apply. So we'll come back here. Again, we'll come from Athena, and this will be country data from our primary work group. Make sure that connection's good, so we got the permissions right. Create the data source. In this case, that's that app 2025 AWS Glue database that we talked about, right? And we're gonna take that country info view that we had. We go back over here. We had create or replace view country info, right? So this is what we're looking at. This is less data. So it's fewer columns, all of them are relevant. So as we go on, this should be a little faster, hopefully, for us to run against. So we'll use country info. We don't have any info to bring it into Spice, which will accelerate everything. I'm not sure why. I probably put something in there and then forgot to remove it. So it's my fault for the rehearsal. But now we see we have these fields again. So if we go to, Treemap, that's fancy. If we give ourselves a heat map, then again, we can set the source country code to be the row, the destination country code to be the column, and the sum of the transaction amounts. Now, if this runs, we're going to get, I think it limits us at 50 country codes in each metric. So we want to go ahead and apply those filters here as well. We don't want to include all. Filter list. This is, yeah, see, there you go. We've got that nice, I think maybe it's 40 by 40 heat map showing because we haven't applied the filters yet. It will cut off and not show everything, which is why you need to filter it to see only the ones you're interested in. And we can see that even though we've got all these transactions were generated using, I think it was faker.js. So they're all 0 to 1,000 units, monetary units. And even though they're randomly distributed, you do see that you get randomly distributed doesn't mean evenly distributed, right? So we do have some heat map issues here. And we said we were going to check from Benelux nations. So we need Luxembourg. Come on, I can scroll faster. There we go. And the Netherlands. Apply that one, and then we can close. And now this will have only 3 rows and, 50 columns or 40 columns, whatever that case is. While that's going, we can add another, right? So you see here, we don't have this axis, but we can see, for example, most transfers from Luxembourg appear to have gone to, somebody help me out, is EE Estonia, I think? Somebody will sanity check me on that one. And of course, again, all this data is fake. So we can add a filter to our source country code. Currently include all, but that's not what we want. We want a filter list. So again, we wait for it to come through. And if you've used products like BI products before, remember we're dealing with massive sets of data here. Like once you have 174 million rows of anything, it's not like querying against 1,000 rows where you get it back. Like, especially the fact that this is all coming in from S3. So, you know, I've seen production queries that take 4 hours in some products. It's not unrealistic. So where did we say? From Benelux to Great Britain, Ireland, or Cyprus, right? Cyprus, CY, Great Britain, GB, and Ireland, IE, right? And we apply those and it'll filter down top 3 in destination country and bottom 50 in source country. So yeah, as you see from this little highlight on here, this is limited to the 50 most common ones that you would use. And now we've got this this beautiful little heat map for our audit to say, okay, these are the countries that we're concerned with. These are, by looking at this, we see that the most transactions are from Ireland to Luxembourg. We've got 19 million there. And then the least transactions are from Great Britain to Luxembourg at 18 million. And now that you're looking at that, you see, well, 18.5 million versus, what was this, 19.1 million, and not that big of a difference, which is where you would, of course, in a real use case, apply your standard deviations and how far outside of that are they truly outliers, and not just use the sum. But I wanted you to have a simple example to visualize what we can do with 174 million rows of data, and how we can begin to look for patterns, or how we can display that to our users. So again, going to be a short session today. I want to come back to our architecture diagram and point out that all of this is happening from that single event going onto the bus. And then the 2 rules are picking it up. And one is taking it through and processing the transaction for us, but the other is taking it out and preparing it for analytics later. And again, the important thing to remember here is all of this has been done serverlessly. The only thing we've paid for is to download that data to run the query, which we have to, and nothing else, right? The storage is already covered by being in S3. The processing is covered at the query runtime. So very powerful service, a good way for us to take what's an abstract back end and then visualize it for our business customers. And as you'll see in this architecture, that's not the first time we've focused on visualization, right? Back at the very, very beginning, we went in and looked at our step functions workflows, and I'll go back to the console for that. One of the advantages of step functions that we've talked about is the ability to sit side by side with the analyst. So we can look at our transaction process here. Did I pick an express workflow? No. Well, that's a simplified one. We can look at our expired subscription process with the analyst and say, is this what you want? And before we begin coding, and then we've taken that all the way through to the very end where we've saved that data and then regenerated a visualization for, this is what our business is doing at this point in time. This is where we need to focus our efforts, is on transactions from Ireland to Luxembourg, and give that very graphical representation. So all of that exists inside this one repo. All of that is done in a collaborative method with your business partner, with your colleagues, whomever you're working alongside. And all of that is done serverlessly. So again, just a very powerful end-to-end method of building applications. Nowhere in here have you had to worry about redundancy or load balancing or patching or any of this stuff, right? All of the benefits of serverless for a complete application, from ingestion to cancellation, processing, and visualization. So I'm going to wrap it up here. Again, like I said, this was a very console-driven episode, so not a lot of code here. But I wanted you to see how quick Athena and QuickSight can really be on massive data sets. Oh, I'm sorry. I said I was going to talk about one more thing here. That's it for our architecture. The registry of open data on AWS. Registry.opendata.aws. 157 as of the recording of this episode data sets that are there for you to work against based on whatever your interest or your business case is. And they're sorted, if you want genomic data sets, if you want, not fraud, what are they? Geospatial data sets. So different data sets that you can use to enrich your queries, to enrich your applications. And again, you don't have to run a database server to get these data sets. You just bring them into your own S3 bucket. Once they're in your S3 bucket, they're there for you to query using Athena, Glue, and QuickSight. So a very visual episode today, shorter one. But again, when we go back and we look at what we've learned, we've talked about how all of that data that we were generating can be pulled in by Amazon Athena. The fact that we want to store it as columnar data using Parquet and compressed for performance and cost reasons. The fact that you can create views and query directly within QuickSight. You can save those views. You can save those queries as named queries that you can then execute from applications using IAM permissions. All of that can be pulled into QuickSight for visualization for your business users. You can also create calculated fields that help do things similar to views, but we showed how the view starts with less data, so it's faster to execute inside QuickSight than the calculated field if you don't need the rest of that data. And then we went over the registry of open data on AWS that you can use to enrich your applications. So this actually wraps it up for us on App 2025 as a series. I'd like to thank you all for joining. I may add some bits and pieces to this over time as we continue to release features. Now that we have step function support in AWS SAM, I'll go back and modify the templates to use that. So some of that cleanup over time, but I intend for this to be like a true living model that you can use to build your business applications. So to that end, I would always welcome your feedback. I would always love to hear what you've seen in here that worked for you, what might not have worked for you, or what was missing. Features that you want to see from us, that you want us to build. My Twitter handle is there. DMs are always open. And then, of course, you know where to find me on Twitch because you're here right now. Again, we'll get this source code up for you as soon as we can. Until then, I thank you all for joining the series. And I wish you the best of luck as you build. Bye, everybody.